Dear colleagues and friends, good morning, afternoon. First of all, I deeply admire academician He-Man for his great contributions to landslide disaster prevention and control. In particular, the NPR constant resistance large deformation anchor cable he developed has truly solved worldwide problems in landslide control, large deformation, high shear, and pre-slip warning. It can still function, provide support, and issue early warnings even during severe landslide deformation or imminent failure, buying precious time for evacuation and emergency response. This is an outstanding original achievement in China's geotechnical engineering, worthy of our study and respect. However, in practical engineering, we have also identified a problem. Many slopes and landslides do not slide violently all at once. Most undergo long-term slow creep, gradual deformation, and slow development. By the time large deformation occurs and requires hours or days of pre-slip warning, the situation is already extremely dangerous and difficult to handle. So I have been thinking, can we develop a monitoring system that complements NPR technology? We do not compete with NPR anchor cables in large deformation, shear resistance, or emergency pre-slip warning. Instead, we take a different approach, monitoring landslides earlier, at an earlier stage, and in a gentler manner. My concept is simple. Use prestressed steel strands, straight boreholes, pre-buried plastic pipes, no or minimal grouting in the free section, and force measurement at both ends. Displacement is monitored through the elastic deformation of the steel strand. It cannot remain intact under 1 to 2 meters of large deformation like NPR, nor can it provide hourly level emergency warnings. But it has one outstanding advantage. It is highly sensitive to early minor deformations. Once the slope shows a few centimeters, tens of centimeters, or even decimeters of displacement, my system can detect it stably and clearly. At this stage, the landslide has not yet developed into severe dislocation. The structure is still safe. We have ample time to analyze causes, formulate plans, reinforce in time, eliminate hazards, and control risks at the earliest stage. In short, academician He-Man Chao's NPR anchor cable is the last line of defense for landslides, saving lives and enabling emergency evacuation at critical moments. Our system provides early health monitoring for landslides, enabling early detection and early treatment to prevent trouble before it arises. The two do not replace each other. They complement one another with different focuses and work in coordination. NPR handles extreme conditions and final warnings, while our system manages early deformation and proactive reinforcement. Combined, they form a complete slope safety system covering everything from early slow deformation to late severe sliding, which is more practical, comprehensive, and reliable for real engineering applications.